Okay, question number 1. Diagram below shows a string to which a small ball is attached and it's executing UCM. UCM means uniform circular motion. Uniform circular motion means you're moving in a circle, hence the name circular, and you have a force acting towards the center. If you're moving in a circle, you'll feel like you're getting pulled towards its center. The force pulling you towards the center is called FC. FC means force centripetal. Centripetal means it loves the center. It pulls you towards the center. Now, by Newton's second law, we know that the sum of all forces when you're accelerating is equal to ma. And the only force acting here is your Fc and your weight, yeah? Now, your weight, we don't really care about it because it's acting downwards. So we just care about your Fc now. Because this is on the vertical axis, this is on the horizontal axis. So we're just going to be talking about the horizontal axis. So Fc is going to be ma, right? In UCM, your A is equivalent to v squared over r. And this is the definition of uniform circular motion. This whole formula. Fc is equal to mv squared over r. And this only happens when you're moving in a circle with a constant velocity. Okay? With a constant velocity with an acceleration, sorry. So, now, list the force acting on the ball. You have a ball over here, you have a string attached to it. So let's write all the forces. You have the centripetal force acting towards the middle, you have the tension, and you have the weight, yeah? So, tension and your centripetal force, which we're going to figure out what it is right now. You have your weight. So you have your tension on the y-axis, and then you have your tension on the x-axis. Tension on the y-axis cancels with the weight since it's not moving on the vertical. So the only force you have right now is your centripetal force. And your centripetal force turns out to be your tension on the x-axis. You know? So Fc is equal to tension on the x-axis. That's the only force acting on it. The rest cancel out technically, you know? Now, I don't know what's going on with part B because I don't really know how to solve it. I think there's missing information. So we're going to skip it and we're going to go to part C. A car of mass 1200 reaches a curve of radius r with a speed of 10. Find the magnitude of the centripetal force. Fc is mv squared over r. R is not given, so we keep it in terms of r. Your mass is 1200 and your velocity is 10 and you square it. So your answer is just this. Whatever r is, you know? And yeah, that's it. Question number 2. Write formula for banking over an aircraft. Simple, it's the same formula. Tan theta is equal to v squared over rg. Theta is the angle with the vertical. Angle with the vertical. Question 3. An aircraft travels in a horizontal circle. Radius is 2 kilometers. Speed is 100 kilometers per hour. Find the angle of banking. Okay. It says banking, so tangent theta is v squared over rg. Your r is 2 kilometers and 2000 meters. Your g is 10. Your velocity is 100 kilometers per hour. You need to change it to meters per second. So you multiply by 1000 over 3000 over 3600, and of course it's all squared. This is equal to 250 over 9. And this entire thing is equivalent to tangent theta. So if we were to solve this, let's solve it, and you get tangent theta is equivalent to 25 over 648. Do the arctangent and we'll get the answer. So theta is equivalent to 2.209 degrees. Okay. Question number 4. The equation is tangent theta is equal to v squared over rg, where theta is the angle done with the vertical. Theta is with the vertical. And yeah, we're done. Okay, so question 5 says, a cyclist makes a turn of radius 20, inclining himself at 30 degrees with the vertical. Find the speed. Okay, tangent theta is v squared over rg. Cross multiply and take the square root. You get this. And now you can simply just, substitute the values. Tan 30 is radical 3 over 3. R is 20, multiplied by 10, so 200. And your answer is going to be some, let's see. I have a calculator with me. So the answer is going to be 10.7456, blah, 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 blah. In question 6, these are your answers. They might tell you this, they might tell you this. V squared over Rg equals to tan theta, or V squared over Rg is equal to mu, coefficient of friction. And sometimes mu is equal to tan theta. This is why this equation exists, you know? Okay, so question 7. It says you have a block of mass 24, it's moving on a smooth horizontal surface, and the force of 120 is acting on it. One force is acting and you're moving to the right. It's pretty obvious you're using Newton's second law. Sum of all forces is equivalent to ma. The only force acting is equivalent to ma. Your mass is 24, your force is 120. Solve for the acceleration. The acceleration is 5. That's it. Alright, so question 8. A block of mass 5 is pushed along a horizontal rough surface. So there's a push, force F, and coefficient of friction. Yeah, there's friction over here. So it's moving to the right. So positive direction is to the right. Okay, what's happening? Okay, cool. Find the pushing force needed to produce an acceleration of 4. That means the sum of the forces is going to be ma, because there's an acceleration. Of course, the friction is backwards. Backwards opposes the direction of motion, so it's negative. So what is your friction? Your friction is just mu n, where n is your normal force, right? Your acceleration is equivalent to 4, given. Your mass is equivalent to 5, also given. So that's a 20. Your normal force, since you're on a horizontal surface, your normal is equal to your weight. So what's your weight? Your weight is mg, which is just 5 by 10, which is 50. And what's your mu? Your mu is 0.25, coefficient of friction. So now we just need to solve for F, which is 20 plus 50 into 0.25. Solve and you get 32.5. So question number 9, two masses, a mass of m and a mass of 3m, are connected by a string and they're being pulled forward by a force F. Yeah, so this has a mass of m, mass of 3m. Let's draw the FBD of this one. Normal, weight, tension 1, and of course you have your friction. I'm assuming it has friction, right? So you have friction. So on the first object, call it object 1, call this object 2. You have T1 minus F. That's going to be equal to, since it's accelerating, the acceleration of the system is 2.5, you use Newton's second law, equals ma. Now let's look at the second object and draw its FBD. Second object has this force acting forward, normal, weight, and it has its friction. Not only that, it also has the tension of it's pulling the other weight with it, yeah, the other object with it. So you have to have the second tension acting with it, yeah. So the second tension minus the first tension minus the friction is equal to ma, right? And sorry, second tension, yeah. So basically the force F, yeah. And now what we have to do is we have to find the tension. We have to find T. So let's find T. What's F? F is mu n, right? So T1 is equivalent to mu n plus ma. What's mu? Mu is 0.4. What's n? The normal on the first object is just going to be equivalent to its weight because they're on a horizontal surface, yeah? So the weight is equivalent to the normal. They cancel out, yeah? So what's your weight? Your mass is m, so your weight is 10m. And plus ma, m is m, and a is unknown. No, a is given to be 2.5, sorry, 2.5. Yeah, that's T1. You solve and you get 4m, you get 6.5m. And that's the first tension. Now, find the magnitude of the force F. So find F. So we found T1 to be 6.5m, and the friction of the second object is going to be mu n as well. but n of the second object is different. It has a different mass, right? Its mass is 3m, and since its mass is 3m and you multiply by g, you get this, right? So 30m, and your mass here is 3m, you have acceleration a, right? So tension is 6.5m, we already did that, so we don't need that, so let's remove it. And now all we have to do is solve. So your friction is equivalent to 3ma, your a is 2.5, so 2.5 by 3 is how much? 3 times 2.5, and that's just 7.5, and don't forget your m, 7.5m plus 30m multiplied by mu, your mu is 0.4, 0.4 by 30 is 12, so you have 12m, plus this one, which is 6.5m. Add them up and you get 26m. Of course, they got different numbers because they're using 9.8 instead of 10 for G. Okay, so question 10, you have a lorry, and that lorry is moving to the right with a force of 2,500 from its engine and a frictional force of 1,200. Since it's moving to the right, positive direction is to the right. This force is positive, this force is negative. And since there's an acceleration, because they want you to find the acceleration, we're going to be using Newton's second law. MA يعني. You want to find the acceleration, you divide by the mass. Your mass is 5 tons, يعني 5,000 kilograms. And that's your answer, which is this much. So question number 11, you have a body, it's tied to a string, and that string is tied to the ceiling of a bus. And the bus is moving forwards. Since the bus is moving forwards, the object is going to move backwards, you know, so it's going to look like this. And it's making an angle of 45 with the vertical. So you have two forces acting, your weight and of course your tension along the string. They're telling you find the acceleration of the bus, and the tension is given to be 550. So since the bus is moving like this, of course you have the tension acting on the y-axis and you have the tension acting on the x-axis. On the x-axis you have no other force but this, so the sum of all forces on the x-axis is going to be ma. You're trying to find the acceleration, so the only force on the x-axis is tension on the x-axis. Tension on the x-axis is going to be the side opposite to this angle, so it's going to be sine 45 multiplied by the force, which is t. So t sine 45 is equivalent to ma. You want to find a, so you divide by m. Your tension is 550, your mass is 18, and that's your answer. And you should get something like 22 or 21.39, you know. So the thing is, since you have this angle, you're trying to find the side opposite, so you multiply it by sine. If you were trying to find a force over here, you'd multiply by cosine because it's the side adjacent to it, you know? That's it. Okay, so question number 12, a massless inextensible rope carrying two objects, M1, M2, M1, M2, and it's passing through a pulley. M1 has a mass of 4, M2 has a mass of 2. If you were to let them go, this goes down, this goes up, heavy goes down, light goes up, yeah? So direction of motion here is downwards, direction of motion here is upwards. Let's draw the FBD. Tension, of course. You have your weight going downwards. Call this object 1, call this object 2. Yeah? Since the direction of motion here is upwards, tension is positive, weight is negative, and it's equal to ma because it's accelerating. Read the question. It says find the acceleration. And let's draw the FBD here. Sorry. Let's draw the FBD here, yeah? So, same thing, tension, you have your weight. And now, direction of motion is downwards, so this is positive now, because it's downwards, M2A, M2A. So let's add up these equations, and let's see what we get. Tension minus W1 plus W2 minus T is equal to M1A plus M2A. Add this to this, and add this to this, yeah? Tension cancels with tension, and you're left with minus W1 plus W2 is equal to M1A plus M2A, right? You can factor out an A. You have A into M1 plus M2. Divide, you have this. In other words, the difference of the weights over the sum of the masses. So, what's the weight of the second object, the heavier object? It's 4 by 10 minus the equilateral object 2 by 10 over the sum of their, masses. And you'll get A is equal to 40 minus 20, so 20 over 6, which is 10 over 3, which is 3.33 repeating. Yeah, that's it. So question 13, you have a man, he's standing on the scale in an elevator. The elevator and the man are both accelerating downwards, so your positive direction of motion is downwards, and they're asking you to get the reading of the scale. The scale always reads the normal force, so let's take the man. Man feels a normal. Man also feels his weight. And since the positive direction of motion is downwards, weight is positive, normal is negative, and since they're accelerating, they're telling you have an acceleration of 1.5, you use Newton's second law, so the sum of the forces is ma, and you just solve for the normal. Your weight is mg, and now you just input the numbers. Just factor out the mass. This is 10 minus 1.5. Acceleration is 1.5. Given mass is 95. And yeah, you get this. Okay, now, so question number 22. Particles, particles of masses 5 and 2 are attached to a string, and that string goes through a pulley. So again, you have a pulley, you have a string, you have mass 2, and that's a string as well. You have mass 5, and they're telling you find the tension. Obviously, when you release these, this goes down, this goes up. So direction of motion here is upwards. Direction of motion here is downwards. Okay, so here you have the tension, you have the weight. So tension, weight. And since it's moving upwards, tension is positive, weight is negative. So it's going to be tension minus the weight is equal to ma. Same thing here, but the weight moves downwards. Sorry, the weight points downwards and the motion is downwards. So the weight is the positive one here. M2A. They're telling you find the tension. Now, A and A are not given, so we're going to have to solve this question without having the A's. So what you can do is you can take the ratio of these two. It's M1A over M2A. So since this is equal, since this is equal to this, then that's the same thing as saying T minus W1 over, and this is equal to this, it's going to be W2 minus T. Now, the A and the A cancel out. M1 is given to be 2, M2 is given to be 5. So the weight here is going to be M1G, which is just 20, and it's going to be M2G, which is just 50. And now we can simply solve for T. Cross multiply 5T. So 20 equals to 2 into 50 minus T. 5T minus 100 equals to 100 minus 2T. Take this to the other side. You get 5T. Take this to the other side. Plus 2T is equal to 200. T is equal to 200 over 7, which is simply your tension is about 28.5, something like that, I guess. Let me just check, am I correct? Yeah, 28.5. The reason why I got 28.5 and they got 28 exactly because they used G to be this, but in the exam you use G to be this. I've said this a million times now. And since we found the tension, let's continue reading the question and see what they want. So find the tension and then find the distance moved by the 5 kilogram mass in 3 seconds. Now we know that the distance is equal to half AT squared plus V0T, right? In the question they said you released it from rest. Rest yani V0 is 0, so this goes away. And they're telling you find the distance that the 5 kilogram mass has traveled in 3 seconds. Now we don't really care about the mass because all we want is the acceleration and the time. The time is given to be 3. 3 squared is 9. So all you need now is the acceleration. But how do you find the acceleration? Let's go back to this equation. Go back up over here, yeah? We have this equation and we have this equation. We found T, and we have W2 and we have M2, so we can find A. Same thing here. You have W1, you have M1, you have T, you can find the acceleration. Doesn't matter which equation you use, you'll still get the same answer. So let's use the first one for the sake of it being the first one. So tension minus W1 equals to M1A. We said that the tension is 200 over 7. We said that W1 is 20. We said that that's 2, so we can solve for A. That would be, let's use a calculator. A is equal to 30 over 7. Now in the exam, you're not going to do all of these steps. You're probably going to be faster, hopefully. So we found A. Let's input A over here. 30 over 7. Use a calculator. You get that. The answer is equal to 19.28 meters or something. What's their answer? 18.9. The reason why we got different answers, again, because they used 9.8 and I used 10 for G, you know? But yeah, we're done. Okay, question 15. A lift of mass 200, a man is inside the lift and the acceleration is 9, and they're both moving upwards. Lift, man, moving upwards, so positive direction upwards, okay? They're asking you find the force between the man and the floor of the lift. Here's the floor of the lift, here's the man. Of course, he has his normal and he has his weight, okay, and it's the weight of the man. And since they're both moving, since the normal is upwards, the normal is positive and the weight is negative, and they're equal to the mass times the acceleration because they're both accelerating. So Newton's second law, solve for the normal. You know, your weight is just mg, and it's that simple. Factor out the mass, substitute the numbers, and you're good. You're Gucci. Yep, and yeah, we're done. So question 16, a lift of mass 250 is connected to a cable and a girl is inside that lift and they're both moving upwards and the acceleration is 15. So you have a lift, you have a girl inside the lift, the thing is moving upwards, any positive direction is upwards, this means positive direction, so this is your tension. This is your entire weight, yeah? The weight of the girl and the weight of the elevator, yeah? So since the positive direction is upwards, tension is going to be positive, weight is going to be negative. So tension minus weight is equivalent to, since it's accelerating, yani Newton's second law. So tension is going to be equal to weight plus ma. What is weight? Weight is mg. Let's factor out m. Your g is 10, your a is given as 15. Your mass is the mass of the entire thing, which is the mass of the elevator plus the mass of the girl. So just substitute the numbers, mass of the girl, mass of the elevator. The tension is equal to this. Yeah. Okay, so you have a block of, on question 17, you have a block of 16 kilograms is placed on that inclination, and you have a coefficient friction of 0.7, and they want you to find the speed, which is the velocity after 24 seconds. So velocity is equal to acceleration times time. Time is given, we need to find the acceleration. So this is how it looks. You have your normal force, and then you have your weight on the y-axis. You have your friction, which is opposing motion, because your direction of motion is downwards. And you just need to find the acceleration. So on the x-axis, these are your forces. And since it's accelerating, you have ma. Your weight on the x-axis is just going to be this weight multiplied by the opposite of this angle, because you want this vector, and this vector is equivalent to this vector. If you want to get something opposite to an angle, you multiply by sine. So it's going to be weight sine theta. What is your friction? Your friction is normal multiplied by mu. What is your normal? Your normal is simply this force, and this force is equivalent to this force because you're not moving on the y-axis. If you're not moving on the y-axis, the forces cancel out on the y-axis. Thus, your normal is equal to your weight on the y-axis. Your weight on the y-axis is this vector multiplied by the side adjacent to 37, so you have to multiply by cosine. So it's going to be wy, sorry, it's going to be w multiplied by cosine, and that's equivalent to the normal. Yeah, w cosine theta. And now we just need to solve for the acceleration. You divide by m on both sides. So now let's substitute. Your weight is mg sine theta minus mu. Weight is mg cosine theta over there, over your mass, and that's your acceleration. Mass cancels with, you know, these things, and that's your acceleration. Yeah, so now let's just substitute numbers. 10 into sine is 0.6 given, minus mu, which is 0.7, coefficient of friction, g is 10, cosine is 0.8, also given, and that's your acceleration. You solve and you get that you have, let's use a calculator, times 0.8, you get 0.56, and that's your A. So your acceleration is equivalent to, no, sorry, I did something wrong. So you solve that and you get 0.4, that's your acceleration. And now you need your velocity, which is A by T. A is 0.4, T is given 24 seconds, you solve and you get 9.6. Okay, question 26. A parcel of mass that is released on a ramp. The ramp is of angle alpha. Angle alpha is equal to arc sine 3 over 5. Yani in other words, sine of alpha is 3 over 5. You know, if alpha is equal to arc sine 3 over 5, take sine on both sides. Sine will cancel with sine, and you're going to be left with this. Yeah? So the sine of the angle is 3 over 5. Particle of mass 5 here, you have your weight, you have your normal. And after 3 seconds, the speed is 4.9. After 3 seconds, speed is 4.9. Acceleration is just speed over time, صح? So your acceleration is just 4.9 over 3. You know, 4.9 over 3 is equal to 1.63. But I'm just going to use it as a fraction, you know, to get a more accurate answer. They're telling you find the coefficient of friction. So we have an acceleration, so we're using Newton's second law. And of course, you're moving downwards. You put a parcel, you put a ball on an incline, and the ball just falls downwards. So you have a weight here, and this weight is going to be W sine of this angle. This angle is alpha. So W sine alpha on the x-axis. Again, you want the thing opposite to alpha. This is equivalent to this, you know. So we're trying to find this. So if we find this, it's the same thing. So W sine alpha, you get this vector, you know, and of course you have your friction. So, and you're moving downwards, so direction of motion is like this. So W sine alpha, friction is negative, is equal to Newton's second law, ma. A, we just found it to be 4.9 over 3. Your mass is 5. Your weight times your sine is 3 over 5. Your weight is 5 kilograms multiplied by 10, so 50. Simplify this, you get 30. And let's find the friction, and then they said find the coefficient of friction. So let's find the friction first. So 30 minus 5, 4.9 over 3, equals to the friction, yeah? But we know that the friction is just mu multiplied by the normal. So mu is this. So we just need to find the normal now. 30 minus 5 into 4.9 over 3 over the normal. What's the normal force? Go back to this diagram again. You have this object, you have this, and you have this, the vertical component. So it's gonna be W cosine of the angle alpha. You know, take it, if you don't understand it, take it as a fact. If you're on an incline, the x value is just gonna be W sine. The y value is gonna be W cosine. When you're on an incline, you know. So here we go. So your weight, your normal, sorry, is W cosine. W cosine alpha. What's W? W is 160, we said. Sorry, W is 50, we said. What's cosine? Well, we have to find cosine alpha now. We know that sine alpha is equivalent to 3 over 5. We can simply find cosine because, you know, cosine squared plus sine squared equals 1. So cosine squared plus 3 over 5 squared equals 1. Let's find cosine. So cosine squared is equal to 1 minus 3 over 5 all squared. Take the square root. And let's see. 1 minus, let's see. You get 4 over 5. Cosine is 4 over 5. 4 over 5. So that's 4 over 5. So this is going to be equal to 40. And this is equal to mu. That's your answer. If you use a calculator, mu is how much? I'm not going to use a calculator. I'm just gonna see what they got. They got 0.546, you know? So yeah, we're cool. We're cool. Okay, question 27. You have this, yeah? Angle 30. You have an object here, connected to a pulley, connected downwards, yeah? Mass of this is 12 kg, mass of this is 8 kg. If you let them go, this is going to move down, this is going to move up, yeah? Because this one's heavier. Okay, so here the direction of motion is upwards, here the direction of motion is downwards. Okay, so on this object, you have your weight and your tension. Since it's moving upwards, tension is positive, weight is negative. So tension minus the weight, let's call this object 2, call this object 1, is equal to ma, because Newton's second law. Yeah? Let's see. Also, here you have the tension acting like this, and you have the weight component. So the weight is like this, yeah? So you have the weight on this object there. So let's draw the free body diagram of this. So you have that, you have the normal, you have the tension acting here, you have the weight acting there, you have the x component of the weight, which is drawn like this. So you have two different forces acting together. The x component of the weight of the second object, of the, sorry, first object. The first object is this object, okay? Minus the tension is equal to ma. So now you have two equations, this equation and this equation. They're asking for the tension. They're telling you solve for the tension. Well, here we go. Did they give us the acceleration though? They didn't give us the acceleration. It's fine. It's fine. We can just take the ratio of this and this. So let's write it here. Minus t equals to ma. This is object 1. This is object 2. Cool. If we take the ratio of this and this, so m2a over m1a, it's going to be equal to t minus w2 over wx1 minus t. Right? Acceleration cancels with acceleration. Mass of the second object is 8. Mass of the first object is 12. The weight of the second object is 80. The weight on the x-axis is going to be so let's look at the diagram again. Here's the first object, and free body diagram looks like this. Weight looks like this. Angle is 30. So you want this. This is the equivalent of this, yeah. So sine 30 multiplied by the weight, w sine 30. So it's going to be w sine 30. What's w? Your mass is 12, so it's going to be 120 multiplied by sine 30. So tension minus 80 over 120 sine 30 is 60. Cool. Minus tension is equal to 8 over 12. Now you can cross multiply and solve for the tension. Let's do it. Why not? I'm just gonna do it really quickly because I can't be asked to do it. Alpha equals, and please feel free to ask me if you don't understand anything from my explanations. Okay, you get that the tension is equal to 72, and yeah, that's it. All right, so look, question 28. So you have two particles A and B of their masses are connected by a string that masses over a pulley. A is on a smooth horizontal surface. B is on an inclined surface at an angle of 45. They're connected to each other by a string through a pulley. They're telling you find the tension. Now here it's a smooth horizontal surface. يعني ما فيش friction. هون ما فيش friction. يعني عندك tension هون, and that's it. Now you would do here is you would say tension is equal to ma, m1a. Let's call this 1. Let's call this 2. And of course, this one's 32 kilograms. This one's 24 kilograms. So it moves downwards. Positive direction is like that. So you only have one force acting, which is T. Newton's second law, T equals to m1a. Here you have B. Here's B. You have the tension acting here. You have the weight acting here. This angle is 45. So you need the weight component on the x-axis, and that's just going to be weight multiplied by the sine of 45 to get the opposite side, you know? So sine 45 multiplied by the weight of b. So sine 45 multiplied by the weight of b, which is 320 because the mass is 32, yeah? So since it's moving downwards, the tension is going to be negative and the weight is positive. So weight of b minus tension is equal to m2a. Weight of b, we just said, is 320, and you need the x components, you multiply by 45. Okay, so now we just need to solve these equations. Now we can't directly solve for tension, because if you simply add these two, the tension cancels out, you know, t and minus t would be 0. But if we do that, we can actually solve for the acceleration. Once we solve for the acceleration, we can find tension. Or actually, you know what? Forget that. We don't need to do that. Take the ratio of both. T over 320 sine 45 minus t is equivalent to m1a over m2a, right? A cancels with a. Now we can just solve for t. Yeah, that's way simpler. M1 is 24, M2 is 32. Yeah, we can simply solve, cross multiply, you know, 24 into 320 sine 45. T, yeah, I can do that, of course I can, minus t. And now you just solve for t. Using a calculator, we get that. What do we get actually? Let's see, what do we get? This is actually pretty fun to do. It's been a while since I've solved questions like this. It's been an entire year actually. So if you do on a calculator, you get 96.9 something. Again, you can just round it and you'll get a 97. But let me just make sure. Let me just make sure of that. So 45 times 120, you get, yeah, you get 96.97, which is 97 almost. And yeah, we're good. So question 21 is a straightforward question about a pilot banks. Banks, yani you use this equation. So you just input the numbers, it's quite straightforward. Rg tan theta. Your theta is 40. Your r is always 10. Your g is always 10. Your r, you have 0.9 kilometers as a diameter. You divide by 2, you get the radius, and you change it to meters by multiplying by 1,000. So your radius is this, which is just 450. So you have 450 over here, and you solve. So this is equivalent to, in the question, tangent of 40 is 0.8, so this is equivalent to 3,600. Take the square root to find v, and you get 60. Okay, so question 22, calculate the centripetal force. Centripetal force means you're in a circle. So you're moving on a circle, let's say in this direction. Your force is always going to be towards the center. This is called the centripetal force, Fc. And Fc is always equal to mv squared over r. V squared over r is equivalent to your acceleration, you know. So in other words, this is just ma. Looks familiar, right? So mv squared over r. Now you just simply substitute the numbers. So yeah, it's quite straightforward. Over the radius, which is 250, and yeah, you get like 3,000, which is just 3 kilonewtons, you know.